Hello and welcome back to AGT STEM. Today we're going to be watching a video about niobium. So, without further ado, let's hop to it.
Element 41 is niobium. And I'd never seen niobium until recently. And then I was lent a medal. I haven't won the medal, but it is a medal that is given each year to somebody who's made a real contribution to the field of niobium chemistry or niobium science. The medal is made out of niobium. So look carefully. This is metallic niobium. I can't remember who won it last year, but it has been won by a series of people, mostly in the field of metallurgy. And I'll explain you why it's metallurgy rather than chemistry in a minute.
So who gave you that one, Professor?
I was lent this by the company CBMM, which awards this medal, together with the Institute of Materials and Minerals. It is named after Charles Hatchett, who was the English scientist who discovered niobium, or discovered the element initially. And it's really quite interesting. It was at the beginning of the 19th century, just after the idea of elements had been published. So everybody was looking for elements, and Charles Hatchett looked at a mineral which had been in a museum in London for quite a long time, a mineral that came from America, and he discovered a new element. And because it came from America, he called it columbium, because Columbia isn't the Latin name that is often used for America. And I think the name columbium sounds really beautiful.
You're normally really opposed to naming elements after countries.
Well, I think it's quite nice when it's named by somebody who doesn't come from that country. Then it's a genuine honour rather than a patriotic gesture. And of course, England had just lost the American colonies, so it was particularly nice gesture. Hatchett, unfortunately, didn't continue as a chemist, and he worked in a company that made carriages, I suppose the modern equivalent of a sports car company, and later in his career he focused on the carriages rather than on the science. The element was then rediscovered in Germany and named niobium. There was a problem because the Americans called it columbium, the Europeans called it niobium, and there was a sort of trade-off. It was agreed the Americans would call it niobium if the Germans and the Europeans would call wolfram tungsten. So everybody was happy. But niobium is actually a relatively abundant element compared to many of the metals. And by far the biggest deposit is in Brazil, where this company, CBMM, is a mining company that digs niobium out of the ground. Now, the main use for niobium at the moment is in strengthening steel. Steel for making bridges, steel for making cars.
So steel is in our cars and in our bridges, and along with the steel would probably be niobium or possibly other kinds of metals.
Steel for making pipelines that you use for high-pressure gas, like natural gas. So imagine this piece of paper is steel. If the steel was just a single crystal, if you put a force on it, like my pulling here, it would be very strong. But actually, the steel consists of small so-called grains, rather like small crystals. The boundary between the grains is a weak point. So let me illustrate that by tearing the paper a bit. Now you can see if I pull again when there's this weak point, it just pulls apart very easily. So the grain boundaries is what causes the failure, and the pipe bursts if you don't make it thick enough. If you add just a tiny bit of niobium to the steel, less than 0.1%, less than 1 part in 1,000, the niobium concentrates along the grain boundary and strengthens it. Let me show you an analogy again. So here we've got our two grains, and you can see this weak point in between. But now, if you imagine the niobium across this grain boundary, it forms a block so that when you pull it, it's much stronger and it doesn't break. I'm pulling really hard.
So niobium is basically just like tape that we put with steel so that it can't fall apart. It makes it stronger so that way we don't have any accidents like pipe bursts or bridges falling from a little bit too much pressure.
What this means is that if you add a small amount of niobium to your pipe, to the steel that you make your pipe, you can put a lot more gas through the same pipe. There's a pipe in China which is 8,000 kilometers long, and by adding some niobium and making the pipe a little heavier, 1.25 times heavier, you can take 2.5 times as much gas down the same pipe.
First of all, that's a very long pipe, and second of all, they made it so you can put like double the amount of gas in it. That seems crazy with just a tiny bit of niobium. It's insane.
Cars, the cars in developed countries like the US and in Europe, they add about 200 grams of niobium to the steel that makes up the car, and that saves 100 kilos of weight of steel in that car. It's almost the weight of a whole passenger. And so then, when you're driving, every 100 kilometers or so that you drive, that saves 1 or 2 litres of petrol, depending how aggressively you drive.
Professor, how does adding niobium make the car lighter?
Well, it makes the car lighter because the steel is stronger, so you don't need so much steel to make the same strength car.
But you said the pipe was made heavier in China. That's because the other things were...
Well, you made it heavier by a little bit, and then you could take twice as much gas in it. In the car, you just want to take the same number of passengers, so you can make it lighter and take the same number of passengers. It's quite difficult to put just a small amount of niobium into the steel. It's rather like adding just a grain or two of salt to your cooking. So, in fact, the producers of niobium produce a material which is called ferroniobium, which is a mixture of iron and niobium, of which I've got some pieces here. It looks a bit black if you crack it open. And so this is the material that is added to the mix when people are making steel. Well, I believe that some metallurgists in America still call it columbium, and I think that's rather nice. But it's not used as a name in chemistry, and in fact I think most chemists will no longer have...
That's kind of similar to the way that we call aluminum foil different than aluminium when we're talking about chemistry, because it, well, first of all, it kind of just sounds better, and second of all, because with the niobium, they made an agreement that they would call it niobium rather than columbium.
Even though the name existed, I like it. It rolls off the tongue so much nicer than some of the modern names for elements, the recently discovered ones. But it's also good because it reminds one of the history. And I think the discovery of niobium or columbium in a sample in a museum is a very good reason why we need to preserve things in museums, because very often scientists who come later can discover things that the people who originally collected the samples would never have dreamt of. The person who originally collected the sample where niobium was discovered didn't know that elements existed. So there was the sample just waiting for the future scientists to discover this.
Thank you so much for watching. That was niobium for you. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!